and it's just really informative as far as figuring out how your server is responsive. You may be surprised at exactly what it's going to do. Logging. This is my standard logging I throw on every server just to get a basic configuration down. The log line prefix gets added to every log in the log file. You may have noticed at some point the default one logs almost no useful information other than the statement itself. There's no timestamp, there's no nothing. This one is actually the example that's given in the PG documentation. This is the format PG expects the data to be in. If you want to be able to do things like, hey PG can you please break down the query times by user and what database it's connected to. If you logged in this format, you can do that. If you didn't, it's not going to be able to do that. And so if you've got historical log data, you may not be able to analyze it the way you would like. Later, a lot of times it's easier to just put it in the beginning. The only thing you're paying is the additional overhead of writing these logs out, unless your queries are really trivial. It's probably driven more by the size of the queries that show up than it is by this little log min duration statement. I recommend setting it to something. This sets it to 1 second, and you can tweak that until it stops annoying you to no end. But what I don't recommend doing is just setting it to some giant value and then just ignoring it like the feature doesn't exist at all. You want to set it to something that it doesn't bother you, but it's still a limit. It's just above where your workload is, because the fact that it's generating no output now doesn't mean that you should go without the protection of when things start slowing down, they start showing up here before they start showing up by angry phone calls and mobs with pitchforks and torches. Temp files are what happens when something doesn't fit in Workman. So if it does the comparison with Workman, it goes, I can't do this in memory, it writes it to a temp file instead. If you log those, you can use that as feedback for, did I set Workman correctly? If you see a lot of stuff showing up there, that suggests, hey, wait a minute, let me find out what those queries are doing. Those are the queries that really could use my Workman, because they're writing all these temporary files out, because I can't do stuff again. Checkpoints, I'm going to do a whole talk just about checkpoints in excruciating detail. I like to turn the checkpoint logging on right from the beginning, because when checkpoint problems do pop, they're kind of odd and mysterious, and if you haven't been logging them from day one, you may not recognize what mysterious means compared to the fundamental. Log connections is probably the first of these I turn off. Once the server gets working normally, you probably don't want to log each connection. But it can be good for initial troubleshooting and trying to figure out kind of, okay, where did this connect and when did it disconnect and stuff like that. Log and lock points is another not necessarily obvious one. You probably want to turn on and set. There's a related parameter called the deadlock timeout that controls how chatty it is. That's set to 1 second by default, so you may be okay. The idea here is every time Postgres goes to acquire a lock, and it has to wait longer than that deadlock timeout number, default to a second, it's going to log that. So if your application, essentially your application that's waiting for something in the database, it can be waiting for a query to execute, it can be waiting to acquire a lock, it can be waiting for the disk drives. Distinguishing between those things, one of those things is an important thing to do. This lets you single out how long was it waiting for the lock as the component to this whole thing. And there's no other really good way to collect that data. So turning that on by default and getting used to that data and some idea of it is definitely a good idea. And then the auto vacuum I already mentioned as well. So this is like what a basic, I want to do what I call defensive logging. Let's log the things that are likely to go bad later before they go bad from day one, and then just get used to what those log files look like. Yep.
Is there a particular reason that you prefer this type of format over than doing the CSV log? Because I know PG is compatible with both.
Right.
Or is it just old habit?
It's more the case that a lot of people don't like dealing with the CSV logs. I'm the wrong person to ask to defend why you shouldn't use the CSV logs as one of the co-authors of the CSV feature. I kind of think it's really cool, but some people just don't like the chattiness of the logs that comes out of those logs.
Okay.
This looks more like a traditional log file that comes out of everything else on your server. The CSV logs, this alternate way you can write them out, is really great, and it's better for analysis than the other ways you can do it, but it's not going to look like the rest of the log files in your system. That kind of freaks people out. So I'll absolutely use CSV logging for a server that I'm managing, but I don't tend to do it by default for other people unless I've had a long talk with them about what logging format is appropriate for. So there's the sort of stuff if you're not logging it, probably should be. Connection pooling, we're a little slower than I'd like to. The quick version here is that connections in Postgres are expensive, and they're likely to remain expensive. The problem of optimizing a large number of connections is not that interesting to resolve for two reasons. The kind of thresholds here is somewhere around 500 active connections, whether or not the connections do anything. Like if they're connected, they're taking up some internal resources and shared memory that the server has to deal with. Somewhere around 500 or so at once, that tends to break down on most systems. If you're on a Windows server, it will mysteriously die with bizarre memory allocations at 125-ish, which is real fun. People go, well, that's ridiculous. I have thousands of users connecting to this database. Why is this limit here at this number? What's going on? The thing to realize, though, two things. One, this doesn't have to be a hard limit. There's external pieces of software called connection poolers that will funnel larger numbers of users into a smaller number of connections to the database. The two that are the most popular are called PG Bouncer and PG Pool 2. The main distinction between them is much like the new and the khaki one is PG Bouncer is a little lighter weight, a little more efficient. PG Pool 2 is heavier, but has some more features that you may find useful to it. So, which is appropriate, and it depends on what you're doing with them. The thing to realize is that modern processors, every time one process that's doing something with memory gets swapped for another process that's doing something with memory, this is very disruptive to the cache of the CPU. And if you have more than some number of those happening at the same time, you get where the CPU doesn't get any real work done anymore. It just pages in the data. And remember, in a database, you're always moving around these 8K blocks of data to represent the stuff that you're doing. By the time you paged in, okay, I need this set of instructions for the CPU, I need this 8K of data to do something for this table, and I need this 8K of data for this other thing. By the time you've swapped all that onto the CPU, you want to actually do some real work before you switch to another process that may have to swap all that stuff back out of cache. So the idea is, if you've got a large number of connections, the last thing you want to do from a performance perspective in any database, this is not specific to Postgres, is let them run it all at the same time. They'll just fight over CPU contention and resources. They don't really get all that much useful done. If your goal is high performance, at a large number of connections, it's unexpected, but the way to do that is to force the database to only handle a small number of connections. Let them queue up instead, let them wait in some other process, let the database finish each query as efficiently as it can, and then boot that thing out of memory out altogether and move on to the next one, so that it's not having all this cache disruption and all this other stuff. It's just really problematic on new CPUs nowadays. So optimal connections performance-wise on a lot of systems ends up being 2 to 3 times the number of cores. That's it. So I've got people who are running 48-core servers and they're going, seriously, I'm supposed to limit this to 150 connections? And they have that attitude until they actually benchmark it and go, oh wow, that does work, doesn't it? So it's something to be aware of if you've got a large number. The idle ones are not as bad. Idle connections in Postgres do not have this